Hello everyone, I'm your teacher, Gao Feifei. This is the practice class of medical statistics. There are 4 practice classes. This is the first time. In our practice class, firstly we will review the theoretical knowledge that we have learned in our theory class. And then we will do some exercises to reinforce our theoretical knowledge. You need to upload the answers of the exercises in your class in time. Every semester, some students ask me if I can tell some important topics of examination. Now, I want to remind everyone, as a teacher, I will never tell individual students the important topics of examination. It is not allowed by the school and it is unfair to others. However, in front of everyone in your class, I want to say that all the exercises we do in our practice class will be the important topics of your middle term and final examination. The same type of question is likely to be examined in your examination. So, you must to pay enough attention to our exercises if you want to pass this course. Before the final examination, there is no need to ask me the key importance anymore. You just need to review what we did in the practice class. What we did is also the important topics of the examination. So pay enough attention to our exercises. As the first practice class, the topic of today is frequency table and frequency graphs. I know we have practiced in the theory class, but few students do it absolutely right. Some didn't name the title for the table and graph. Some didn't put the title at the correct location. Some tables contain vertical lines. Some tables didn't keep the same decimals of values in the same column. Some graphs didn't name the axes, and many other problems. So we set up a separate practice class to practice the frequency table and graphs. It is very important in medical statistics. We often examine the frequency table and graphs in your examination, so you must to know how to construct the frequency table and the graph for different type of data. Now, today, firstly, we review the theoretical knowledge that we have learned in our theory class. First is the structures of a table. Title, subheading, subheadings, lines, tabular values are required for each statistical table. Footnotes are not required if you don't need any additional explanation for the table. The title must to be located at the top of the table. Briefly describe the content of the table. Subheading include vertical subheadings and horizontal subheadings. Horizontal subheading indicates the information of each row. In general, our grouping variables are often used as horizontal subheadings. Vertical subheading indicates the information of each column. In general, all research indicators are often used as vertical subheadings. There are a total of 3 lines in a table, including the cap line, the bottom line, and the line between the vertical subheadings and the observations. Only horizontal lines are permissible in a table. Any other lines should be omitted, such as the vertical lines or diagonal lines. Only the Arabic numbers can be shown in the table. If units of measurement are involved, they should be located with the vertical subheading. The number of decimals of values in the same column must to be same. Those are the structures of a table and the basic rules and the demands of making tables in statistics. The frequency table is the most widely used table. Depending on the different type of numerical data, the frequency tables are different. We know there are 2 types of numerical data, including numerical discrete data and numerical continuous data. For numerical data, the value of observation can be marked by exact numerical values that arithmetic operations can be applied to. But numerical discrete data only take integers. It is not allowed to take a value with decimal. For example, the number of teeth of a baby. That may be 16, that may be 10, that may be 8. The number of teeth of a baby is a numerical discrete data. Continuous data allowed to take any value. It allowed to take a value with decimal. For example, the weight of a baby. It is the difference between the discrete data and the continuous data. The discrete data just take an integer, but for the continuous data can take any value. For discrete data, the frequency table lists the frequency distribution of various values. But for continuous data, the frequency table lists the frequency distribution of different intervals, as the value of a continuous data were often divided into different intervals. Now, let's look at the frequency table of discrete data. We take this table as an example. Firstly, we should order the value from the smallest to the largest. List the various values in the first column. 0, 1, 2, 3, 4, 5. List in the first column. Then we count how many numbers are the same. That is the number of times of each value, the frequency of each value, listed in the second column. The total frequency is the total number of observations, 16. Additionally, the frequency table also displays the relative frequency of each value. So now we need to calculate the relative frequency of each value. Divide the frequency of each value by the total number of observations. For example, the relative frequency of the value of 0. Now the frequency is 1. Now frequency 1 divided by the total number of observation 16 is the relative frequency. So you need to calculate the relative frequency for each value. Use the frequency of each value divided by the total number of observations, 16. Now we can get the relative frequency of each value listed in the third column. Now this table has 3 columns. The first column displays the ordered value. The second column displays the frequency distribution of our value. And the third column displays the relative frequency distribution of the data. But now, we haven't finished all the work. According to the rules and demands of making statistical table, we need to add a title for this table. Maybe we can name it as Table 1, the frequency distribution of decade teeth, and then put it at the top of the table. And then add 3 horizontal lines for this table. Also, you can add a total line, but the total line is also a horizontal line. In general, a statistical table contains 3 horizontal lines, the cap line, the bottom line, and the line between the vertical subheadings and the observations. You can also add a total line, but the total line is also a horizontal line. Remember that only horizontal lines are permissible in statistical table. It is the frequency table for numerical discrete data. We can also represent the frequency distribution of discrete data using the bar chart. We take each value of a verb as the horizontal axis, and the frequency or the relative frequency as the vertical axis. Now, the length of the bar indicates the frequency of each value of a verb. The higher over the bar, the larger frequency or relative frequency of that value is. Besides, please don't forget to name your horizontal axis, vertical axis, and the title of the graph. The name of the horizontal axis and the vertical axis should be located next to the axis, like this graph. The title of the graph must to be located at the bottom of the graph. It is the bar chart. Also displays the frequency distribution of numerical discrete data. Those are what I want to say about the frequency table and the frequency graph for numerical discrete data. But for numerical continuous data, how can we construct the frequency table and the frequency graph? Numerical continuous data can take any value. It is allowed to take a value with decimal. The value of each object may be different from each other. If the frequency table was still constructed as numerical discrete data, it may be just displayed the ordered data only. Now, we need to divide the continuous data into different intervals. And then we count out the frequencies of each interval, and then calculate the relative frequency of each interval. Just like this table. The first column displays different intervals. The second column displays the frequency of each interval. Now, the third column displays the relative frequency of each interval. The key step to construct such a table is to subdivide the observations into different intervals. So firstly, we should determine the number of intervals. The appropriate number of intervals should be between 8 and 12. You choose the number of intervals between 8 and 15. And then we determine the range of the dataset. The range is the difference between the largest value and the smallest value. We need to subtract the smallest value from the largest value. It is the range of your dataset. And we use the range of the dataset divided by the number of intervals. Now we can get the width of each interval. So next we should determine the width of each interval. Use the range of the dataset divided by the number of intervals set the width of each interval. Next, we need to determine the low bound and upper bound of each interval. Now, we must to make sure that the intervals include all possible values and don't overlap. Each interval is starting at some low bound and ending at some upper bound, with the low bound inclusive and the upper bound exclusive. Besides, the low bound of the first interval must to be smaller than the smallest value. And the upper bound of the last interval must to be larger than the largest value, so that all the intervals contain all possible values and don't overlap. After we determine each interval, the low bound and upper bound of each interval, now the next task is to count the frequency of each interval and then calculate the relative frequency of each interval. The first column displays the different intervals. The second column displays the frequency of each interval, and the third column displays the relative frequency of each interval. Of course, now we still need to name a title for this table and 3 horizontal lines for each. It is the frequency table for numerical continuous data. Same as numerical discrete data, we can also represent the frequency table using a figure. This figure displays the frequency distribution of continuous data that we call it as a histogram. We take the intervals of values as the horizontal axis and the relative frequency density as the vertical axis. Now, the relative frequency density is the relative frequency of each interval divided by the width of each interval. The relative frequency density is calculated using the relative frequency of each interval divided by the width of each interval. Now we take the relative frequency density as the vertical axis to construct the frequency graph for numerical continuous data. So now the height of each rectangle is the relative frequency density of each interval. Now, the area of each rectangle is the relative frequency of each interval. Now, the sum area of all rectangles is the sum of relative frequency of intervals that is 1 or 100%. Such frequency graph is called as the histogram. The histogram is showing the frequency distribution of a numerical continuous data. And there is no break between intervals, so there is no space between the rectangles. But for the bar chart, the frequency graph for numerical discrete data, the bars are usually separated by several equal length space. Because the bar just represents the frequency or relative frequency of only integer. There is no value between integers, so the bars was separated by space. The bar just represents the integer's value. But for the histogram, the height of each rectangle represents the relative frequency of each interval. There is no break between intervals, so there is no spaces between the rectangles. Those are the difference between the histogram and the bar chart. One is for the numerical discrete data, and histogram is for the numerical continuous data. For the bar chart, we take the relative frequency or frequency as the vertical axis, but for the histogram, we take the relative frequency density as the vertical axis. The area of each rectangle is the relative frequency of each interval, and there's no spaces between the rectangles. But for the bar chart, the bars were separated by spaces. So those are the difference between the bar chart and the histogram. Lastly, we also can't forget to name a title for your histogram. And the title of the histogram must to be located at the bottom of the figure. We know the title of a table must to be located at the top of the table, but the title of a figure must to be located at the bottom of the figure. This is the difference between the table title and the figure title. One is located at the top of the table, but for the graph, the title of a graph must to be located at the bottom of the graph. Now, those are the theoretical knowledge of today. Now, you need to complete the following exercises independently and upload your answer in class. The first exercise is to construct the frequency table and graphs of numerical discrete data. Now, the second one is to construct the frequency table and the graph for numerical continuous data. This is all for today's class. Okay, now it's the time to finish your exercise. Come on, everyone. Bye-bye.